Okay, so I am preparing for a final, so that means you guys get to as well. And first problem we're gonna do is this number 10 in the advancement sample exam. And I'm gonna turn on my annotation here, turn on my drawing, and let us begin. So the question is, for an ideal transformer shown below, find the power delivered to the load. And the load, because I've seen the solution, is talking about this, even though to me it seems like the load is this entire thing. So what we do, start off with, is we find the reflected impedance. So we're going to start with this circuit right here. So the reflected impedance is just the impedance of the circuit. So 10 plus 20J all times this number right here. It would be this number right here, the whatever is in the 10, the primary number, over whatever's in the secondary number. So it's 10 over 1 10 over 1, and in this case, well, in every case, it's that number is squared. So we have 100 over 1 times 10 plus 20J to give us a reflected impedance of 1000 plus 2000J. So remember that 1000 plus 2000. So we had the 1000 plus 2000J. Now we make our circuit, our I1 circuit, to be and since we have our dots right here, we're not going to get, it doesn't need to get too complicated, even though finding power is going to be the same whether this part is positive or this part is positive. Power is still the same. So we have our original 1000 we have our 1000 ohms here, and then our reflected impedance is going to be this number, the 1000 plus 2000J. So what we want to do is find V1. And you can do this a number of ways. I chose to take the current, which is I1. So I take 1000 divided by 2000 plus 2000J, And that yields 0.25 minus 0.25 J. And then I multiply that value, this value right here, times 1,000 plus 2,000 J to get my voltage, which is 750 plus 250 I. And then from here, I know that this 750 plus 250I is at a 10-to-1 ratio, which means for every 10 volts on this side here, there's 1 volt here. So I'm going to divide this number in half, or not in half, by 10 to get 75 plus 25I. So remember the 75 plus 25I. So now I have a voltage source here. What is essentially a voltage source? And like I said, it doesn't matter in this case, but because of our dots are here, then I don't have to think, then it's not inverted. So we have our 75 plus 25I This got a fantasy touch on my iPad there. 25I. And then we have our load here. Which is 10 and J20. So we divide 75 plus 25 by 10 plus J20 to get 0.35. 0.353 angle negative 45 degrees. That's our current. So then then we have our current, and we need to find out our ZL. So it's going to be, current is I squared RMS. Our power is I squared RMS times the resistance. And that's just basic Ohm's law, which is times 10. So we have 0.353 angle negative 45 squared. And like I said, we only care, because power, we only care about the real part. So then we get our answer of approximately 62.51 watts. If it was looking for the complex power, it would be a similar answer, but in VAs. But we are looking for the power. Oh, sorry, I skipped a step here. Skipped a step. So we have our 3.536 squared, or because it's IRMS, we're taking this 3.536 divided by the square root of 2 times 10. And then that yields us this number right here. All right, thanks for watching.